The 10th element on the periodic table of elements is neon, my favorite element. This is Norris Teaches Science with me, Mr. Norris, another physical science edition video. Today we're going to talk about isotopes. So the video goal is I can explain how isotopes are similar and different in the calculation components of the atom. So what are isotopes? Isotopes are atoms of the same element. Same element. So since they're the same element, they're going to have the same atomic number, but different mass numbers. So you can see here C12 and C14. They're both carbon. That's what the C means. They just have a different mass number. One has 12 and one has 14. That is because protons stay the same, but neutrons will change the number of them. So if you look here, each one of these has 6 protons. This has 6. This has 6 protons. But this over here has 6 neutrons, and this over here has 8 neutrons. So let's look at how they're written and use it to calculate some. So how isotopes are written, you either have the element's name or the element symbol, a dash, and then a number. That number represents the mass number. All right. Before we go any further, you should have your periodic table with you. Look up what oxygen's atomic number is. The atomic number of oxygen you should have found to be 8. All right. So this oxygen has a mass number of 16. This one has a mass number of 17. And this one has a mass number of 18. Hopefully you watched the last video about the atomic structures and how to find protons, neutrons, and electrons. If you don't, I will review it here. But protons, how do you figure out the number of protons? It's always whatever the atomic number is of that element. This element is oxygen, so the atomic number is 8. We're messing with oxygen with all 3. So all 3 are going to have 8 for its protons. Neutrons, however, we do a mass number minus atomic number. So oxygen 16, the mass number is 16. We're going to subtract 8 from it, and you should get 8. Oxygen 17, the mass number is 17. We're going to subtract 8 from it, and we get that there's 9 neutrons. See the difference between the first two? The number of neutrons because of the mass number. The last one, the mass number is 18, and we got to subtract the atomic number of 8 from it, and we get 10. So all 3 atoms are the element oxygen. The difference is that this one has 8 neutrons, the second one has 9 neutrons, and the last one has 10 neutrons in the nucleus of the atom. Now, why is mass number as decimal? And this relates back to the isotopes. The mass number is the weighted average of all the isotopes of an atom. So you have to take all the different mass numbers. So like oxygen, we had 16, 17, 18. We have to figure out the weighted average means what percent of all the elements all the atoms of oxygen are oxygen 18. Do this whole calculation, kind of like how your grades usually figured out in class. And it gives us the mass number as a decimal. Now, if you look here, chlorine, you got chlorine 17, you have 2 mass numbers here, 35 and 37, but the mass number is usually 35.446. So that means the mass number is 35. What that means is that the 35, chlorine 35, is the majority of the masses. So if we take, say, oxygen's mass, so oxygen mass number is 15.99. We round that and we get 16. That means oxygen 16 is more abundant than in oxygen 17 or oxygen 18. And just throwing this in there, sometimes this happens. Most atoms are neutral, but sometimes they actually do get a charge to them. They can get a positive charge or a negative charge. It's all about the electrons when it comes to the charge of an atom. If the atom has a negative charge, it has gained an electron, and if it's positive, it's lost an electron. Because remember, electrons have a negative charge. You can't lose protons because if you lose a proton, you change the element. So if you had like 5 protons and then you lost 4 protons, you've changed the element. But we can gain and lose electrons and still have the same element. We just have to give that atom a charge of a positive or a negative. But I hope you learned a little bit today about isotopes. If you want to know more, go out, Google it. But I'm Miss Norris, and I'm out for this video.